Hello world. After a tour of part-time jobs during my college years, I finally decided to join the IT job market. My first job was to create a data warehouse for an electricity company back in Portugal. This was about the same time that smart grids and smart meters were starting to appear. I've always wondered how complex the smart grid must be, what algorithms keep it running, and what are the people behind those algorithms. On this first episode, we speak with Giuseppe, a data scientist and a data science manager at Dexter Energy, a company in the Netherlands working on AI and energy. This is a conversation about his journey, advices for first-time engineers, and of course, a little bit of a Gen AI. Hope you enjoy it. Welcome to Away from the Keyboards. So, I'm curious, what is the story around that? Like, what made you move from Italy to the Netherlands? How that story went?
Yeah, it's indeed it's a bit of a story. Let's start with the fact that when it comes to choosing sort of computer science or computer science or computer engineering, I chose at a very young age because I was always passionate and always a nerd inside and always passionate about technology and especially computers. I started my first computer at home arrived when I was 8, I think. My father was an engineer, so he sort of needed it. And then the first basic programs started not long after. But yeah, I knew for a very long time. So I did my bachelor in Sicily, actually. That's where I am originally from. Then I moved to the north of Italy for my master's to Turin, which is one of the best universities in Italy, the Polytechnic of Turin. And then after graduating, I was like, okay, I could go for a job, just like normal people do. And I sort of looked around, but then back then I remember I mostly interviewed for these big consultancy companies, and I immediately felt that was not the right place for me. I didn't find a good match back then. And as a suggestion from my sister, I decided to apply for a PhD scholarship because I really liked my master thesis. My master thesis was about software engineering, and specifically green software. So energy efficiency of software applications, which, back in the days, this was 2011. So yeah, it was not yet very sexy, I guess, or very popular, but for me, it was already a thing. And so I applied for this PhD scholarship and I got it, which I was very happy about. So then I had to decide, okay, do I do a PhD? Maybe with a very low salary, but then, with the prospects of maybe going abroad and doing some other stuff? Or do I just, look for a job and settle down, quote unquote? But then again, also for a very low salary, right? Because the entry-level salaries in Italy for a new graduate are really, really bad. So yeah, in the end, I went for the PhD because, as I said, I really liked my master thesis and I really liked my tutor, my professor. We worked very well together. But then when I started, I immediately told him, look, it's nice and all to do a PhD here, but what I really want is actually going abroad, because I did an Erasmus program while I was doing my master, actually, which it's a bit already uncommon because you normally do Erasmus during the bachelor. But then I decided to do it during my master, and I went to Spain for almost a year. And I loved it. I really enjoyed living abroad, meeting people from all over the world, or Europe anyway, in this case. So I was like, yeah, that's my dimension, right? I don't really need to be stuck in my own country. I can go around. And that's the amazing thing of the European Union, right? Yeah, so then basically I started the PhD, and then 1 year into the PhD, I went to a conference in Zurich. It's one of the most important software engineering conferences. Well, actually, the main software engineering conference, which is called IKEA, International Conference of Software Engineering. This was 2012. And I met a professor from the VU University in Amsterdam, the Free University, which was, she's actually Italian, but she was working here in the Netherlands, in Amsterdam, on the same exact PhD topic that I was working on. And fun story, she actually knew my supervisor because she was working at my university as well for a while she was still in Italy. So there was a fantastic network, a great connection. we met, I introduced her my work, and she was like, yeah, why don't you just, come over to the Netherlands one of these days, and, you do a pitch or something, a presentation, you show us your work. I was like, yeah, sure, let's do it. And then, I went, and then from a presentation, it became a research visiting period, and then eventually it became a basically double degree kind of program, but as a PhD candidate. So it's called a co-tutorship, where you basically can get a PhD from two different institutions. And actually, these two things that you see here are my two PhD titles. So it's the same stuff, right? It's one PhD actually, but it's, I get two pieces of paper from it. So that's cool, I guess. So that's what brought me essentially to the Netherlands. Long story short, I moved in March of 2013. And again, back then I didn't know for how long, right? Because it was intended as a research study period, but then eventually turned into a more permanent settling down than I originally had imagined. Yeah, so my PhD was in specifically on what would you call now green IT. So essentially, the main focus was how to improve the energy efficiency of software applications. That was my PhD topic. But then, of course, when you start working into this space, you also get exposed to all sorts of sustainability related topics. So I also did some work in things like renewable energy, smart grids. I started looking into ways in which you can use software to basically help the energy transition, the stride against climate change and sustainability. There's always been my let's say mission, and what actually really motivates me to keep going, and still doing it to this day.
That's super cool. And one of the things that I would like to understand, but how important was what you chose during your study for your first job? Because you ended up working for an energy company, right?
That is correct. Yeah. So that is a good point. Obviously, like my PhD was on a very academic topic. And even though I did a lot of practical stuff, like I ran experiments, I wrote a lot of code, but I wouldn't say that had an immediate industrial application, right? So in the end, I had to sort of at some point make peace with the fact that if I really wanted to have impact, and if I really wanted to go into industry, to have a more non-academic environment around me, then I needed to pivot to something else. But the truth is, when you do a PhD, it's more than just the topic you study, right? Well, first and foremost, of course, I had a PhD in software engineering and specifically in software architecture. Immediately there, you are exposed to a lot of knowledge and a lot of things that are not only related to what you're doing. I learned a lot about software architecture, learned a lot about, lots of theory, of course, but also practice. I talked to a lot of companies. I did a lot of real case studies with developers, interviewed them. So it's not like it was all theoretical. And then you also learn a lot about, soft skills, so to speak. So when you do a PhD, you have to typically coordinate master thesis projects. You have to teach. I actually had to teach a course that I designed myself called the Green Lab, where we were basically teaching other students on how to do experiments on software energy efficiency. And the course is still going on to this day, which I'm very proud of. It's run now by a very good friend of mine, Ivano Malavolta at the VU. It's a lot of experience, actually. It's not just studying, and it's not purely academic background. And of course, it's also about what you really want to learn and how you want to shape your own profile. There was, I have to admit, when I started looking for a job in industry, there was a bit of an imposter syndrome that I felt like, oh, am I ever going to be good enough to actually, write code and work in agile or, deploy to production, this kind of stuff was
on a Friday.
On a Friday, yes, exactly. YOLO at 5 p.m. Did it so many times. Probably shouldn't say this on a podcast. But yeah, so that's very typical for academic people with academic background to feel that they're missing something, right? But then in reality, we're suddenly looking around. I felt like, I had a lot more things under my belt than just my coding skills. So that's why I then decided to make the move. And indeed, my first job after academia was an energy company, Vandebron, which is a Dutch energy supplier, purely working with renewable energy. And I had the opportunity opportunity to work on a super cool project, which was essentially developing a smart charging algorithm for electric vehicles to balance the energy grid. So there was a project that Vandebron had in collaboration with Tenet and with IBM, which then culminated into the development of this platform they called Equigy, like equity and energy, right? So yeah, you can look it up on the website. I can also send you the link later, but it's still going right now. And yeah, it's pretty cool because essentially, trade this energy of all these vehicles in real time by steering them, stopping charging, starting charging. You can also do it with batteries. You can even do it with wind turbines these days. So it's, it was quite a lot of fun to work on it and to build it at the very beginning. And again, I started as a data scientist originally because, of course, through my PhD, I studied a lot of statistics, I worked a bit with machine learning. I analyzed a ton of data. So that was something that I knew how to do. And I mean, obviously there was a steep learning curve, but because of course there was a specific problem on the energy market, I had to study a lot of mechanisms on how the energy market works, etc., the day ahead, per day. But then eventually I fell in love with it so much that now I'm incredibly happy to work in this sector. It's one of the most rewarding things that I did in my life, to really get into the nitty-gritty details of how energy works, really, how do we use electricity, how is it generated, how is it stored, how is it traded. It's fascinating and very, very, very relevant for the times we live in. So yeah, I wouldn't go back.
Yeah, I was thinking, I guess this is a feature that we really don't have that much in the Netherlands, which is hydroelectric, right?
Yeah, we lack something called elevation for it.
Yeah, exactly. Which is kind of a cheat code. If you have a country with hydro, you can just pump your extra energy back into pulling the water up the reservoir, and then you use it in a later date. So when you don't have that cheat code like the Netherlands, what are the solutions? It's basically batteries.
Well, yes, it has to be said that the Netherlands also depends a lot on the neighboring countries like Germany or Denmark, Belgium, of course, or France. There's a lot of interconnections between the European countries these days, especially Central Western Europe. But yeah, it is true that the Dutch grid is heavily congested because, of course, it's a very densely populated country, and electricity is just the electrification is going on in full force. And of course, you can have moments of very sort of high exchanges on the energy market because indeed you don't have these buffers. But typically these are solved by the unified energy market across Europe, and that allows you to sort of account for this lack of flexibility, so to speak.
Oh, so that's cool. Basically, you can export your extra energy to different countries, and that way you don't really need to worry about pumping it up amount to put on a hydro.
Yeah, correct. I mean, obviously there are costs related to that, and mostly it makes your energy price dependent on other sources, right? So that means that, for example, for whatever reason, a coal power plant trips, as we say, so shuts down unexpectedly in Germany, then you have repercussions on the Dutch energy grid, and it's usually a bad day on the market or a very good day for some, right? So depends a bit on which side of the market are you on. But indeed, like the Netherlands is a pretty unique country geographically. It also has installed in the past few years a humongous amount of renewables, especially solar, up to the point where basically now we are in situations during summer, for example, where energy is so cheap that actually you can have called negative prices. Basically, you can buy energy at a negative price, which means that you actually paid for consuming it. So it's quite an interesting situation. And that, of course, it requires a bit of thinking because it's something that is a bit hurting the business case for renewables in a way. It's a bit of a complicated market dynamics, but basically the energy for solar, for example, during peak hours is so low that a lot of solar asset owners are not really making money anymore on this power. It's too cheap.
Yeah, it's a complicated market. But luckily there is guys like you looking into it to try to make it a bit better.
Yeah, we're doing our best.
So you were saying that one of the things when you started your first job that you had to learn about the energy market and how it worked, and you learned soft skills during your postgraduate. How would you rate it in terms of a percentage for someone that is starting their first job? Hard skills versus soft skills?
I don't know whether the distinction is so clear. Let me tell you what I mean, right? Obviously, you have things like, just your pure knowledge of a programming language, right? Or just your pure knowledge of libraries and stuff like that, right? Or architecture. But the truth is, a lot of times building software involves things like communication, for example. It involves things like writing stuff, right? Documentation, or just, good commit messages or PR summaries, right? As in pull requests, not public relationships. It's actually a less clear line as we would think. So, for example, when I started working, I knew quite well how to code, right? In some language. I knew Java and I knew R, not even Python back then. And also I had a lot of theory. So I could pick up new languages fairly easily. So at Vandebron, we mostly use Scala, which it's a bit of a different language than Java, although, there's a lot of similarities. But that was not the problem. The hardest thing for me was like learning how to do good commits. For example, how much of change should actually be in one commit, right? Because then when people reviewed my PRs, were like, oh, this is a mess. Like there's so many changes. How do I review it, right? And then, if you go commit by commit, then it's usually clearer to understand the flow and what's happening, right? Or again, for example, obviously these days with ChatGPT and all the sources you have online, right? Developers are so much supported in their work, right? That, sometimes the syntax is definitely not the biggest concern. But then again, you have to learn when to sort of copy paste code from, or you shouldn't copy paste code from, ChatGPT or Stack Overflow without understanding what it's doing, right? And that's also involves maybe talking to other developers and asking, hey, what do you think this means? And what is the best solution? And, there's some amount of soft skills in there as well, I would say. It's not easy to draw a line in there. Having said that, I definitely think doing a PhD helps you a lot in things like knowing how to do presentations, knowing how to talk with non-technical people, which was a huge deal in my job. Actually, when I started at Vandebron, after the first, I think it was even 6 months, I went from sort of being a data scientist in the team. I was also doing the interim product owner role because I could talk to stakeholders, right? And then after not even a year, I became a manager because, at that point, it was clear that like my ability to communicate with non-technical people, my ability to translate requirements into words, basically, or into code and to also sort of plan work, et cetera, and understanding more architectural concerns was more a skill for me than just, your pure individual contribution, like your pure coding productivity. So I would say that depends really a lot on what kind of person you are. And by the way, right, I also think we need in teams people that are very deep and focused workers, right, and coders. So people that, need to sit behind the laptop for a whole day and just build awesome things. So I really think it depends a lot on what kind of person you are, what makes you tick, and what are the things that come more natural to you.
When we speak about software engineers, data engineers, the idea is that there is a solution fits all. And when we speak about something like, oh, you want to have a cross-functional team, you just think about, you want a front-ender, a back-ender, a UXer, and a data guy in the team. But in reality, sometimes it's more important to really have those skills in your different engineers, because someone will have to speak your top product owner. You'll have to have the guy that is so much into the code, that is producing a lot of it, or maybe reviewing a lot of the PRs and teaching the rest of the team how don't do a pull request with 50,000 lines of code. No one is going to review it after. Those type of things, right? Quite interesting, because we just talk about the role as one role, but in reality there is it's the T-shape kind of theory, right? You have your very much hard skills of software engineering, but maybe you dabble a bit on the product ownership, and you're able to tell requirements to business people without going deep into catch try or something, something in those lines, right?
Yeah, absolutely. And like you said, it's really about this mix of personalities in a way, and this mix of seniority, right? So I would say, as a neo graduate, what you should do, you should sort of glue yourself to the beside a senior guy that is willing to teach you and to mentor you, because you need that mentoring, right? You really have to go through it, and you have to have these people that, really take you by the hand and sort of bring you. And if you're talented and you're ambitious, then you're also willing to learn, and you enjoy learning a lot of these things. And eventually you will become, an independent contributor that can do these things for other people as well. And I definitely think that it's something also that we teach way too little in university. And yeah, definitely we emphasize a lot in the hard skills. I don't know, the distributed systems, algorithms, CAP theorem, all these kind of things, formal methods, which is super important. Definitely not downplaying that. But maybe when it comes to real software development, we should also emphasize how much collaborative it has become, right? The era of the rockstar developers that code a system by themselves is gone, right? That doesn't exist anymore. Maybe now with AI, a single software developer can do a lot more, but anything that requires some degree of complexity and interaction requires a team to work on. And yeah, it's also a healthy thing.
Yeah, you're talking about AI, and now it's all the rage, right? And we all like to generate our code in ChatGPT or DeepSeek code or Llama code or whatever is the new craze that comes from that. So I was thinking today about something, and wondering also about picking your brain around this. I've seen the interview a while back with Zuckerberg. He was saying that, well, we are a couple of maybe months away of having an AI that is like a senior developer. But what I see the value on it, because I was trying to reverse engineer an APK. And when you reverse engineer, the code comes all gibberish. Like it doesn't have the proper names, but you can just dump that into the AI, ChatGPT in this case, and ChatGPT started explaining to me what the code does, even like all the function names are cryptic. So I started thinking like that is probably a really good business case for AI, because most of the times you write code 6 months after, you don't really remember that you wrote that code, right? You go git blame, who wrote this? Oh, it was me. Oh. Interesting. Oh, yeah. I'm a smart dude. That's really cool. But that could be an accelerator that really comes into play, not just the production of boilerplate code, that most of IT is boilerplate code, like you get it from other repos or open source or whatever, but also the coming and explaining like, oh, okay, remember this function that you wrote 6 months ago? This is how it works. Right?
Yeah. So explain it to me, please.
Exactly. So we are from the data world, which is a bit different from hard code software engineering. Yeah. If you had to guess, if you had to speculate, where do you see like the biggest value of these AIs like Copilot and so on coming into the picture?
I recently listened to a very nice episode of the Pragmatic Engineer podcast from Gergely Orosz with Grady Book or Butch. I think it's Book. I'm not entirely sure how to pronounce it, but basically he's a very famous software architect, you would say, or anyway, pretty much a guru in software engineering. He was one of my heroes when I did my PhD. And among other things, he's the creator or co-creator of UML, to name one. Obviously, they also talk about this. And I think I very much agree with his stance, which is, at the end of the day, software engineering is a history of increasing levels of abstraction, right? I mean, and that's just what it is, right? So you start from assembly, then you move into, procedural code, then you move into object orientation. And this is probably one more level of abstraction where it might even be that, the code dimension, as in, us looking at code and writing code, might be a thing of the past, right? Maybe programmers will use a lot more natural language in the future and then have the machine write code for them. There's a lot of implications which I'm not going to get into, but for me that is what makes sense. And then things like code obfuscation, like what you were just telling me, right? So the practice of hiding the meaning of your code by using a lot of nonsense ASCII characters, that's probably something of the past, right? That doesn't work anymore. So a lot of these things will just become obsolete, but then they will move to other levels of abstraction. So for example, I don't know, trying to fool your AI with some weird prompts or stuff like that. I don't know, right? So there will be other issues, that's for sure. But at the same time, I do think that this is what we are experiencing right now, that we're witnessing this transition of going from having to really understand what each single instruction in our code does to maybe not necessarily having to care that much, right? And being able to write a high-level instruction that then generates the code for us. And then, if we wanted to make it efficient, then we ask the machine to make it efficient, right? So I think that's a bit what is happening, which, I'm quite neutral about it. I think, as with all things, you can use it for greatness and you can use it for very, very awkward use cases. That's a bit my view. And of course, I do think you have to use it, that you would be an idiot not to. And I do think, and especially because we are in the data world, it's also very important to understand how these machines like LLMs work. And just on unsolicited opinion, I do not believe that they will lead to AGI. I do think that for AGI, we need a little bit more complexity than just a stochastic parrot that is able to infer words. But that's just my opinion. But I do believe that they are very useful tools for a lot of stuff, and that we should use them and make the most out of them.
Exactly. They are. I see them now almost as the old promise that we had of code blocks, where you'd have like magic code blocks that always did the things, and then you start connecting them together, and you can do the same thing with the prompts, where you say, I need you to create me a function that will do a timer of 50 seconds, but receives a JSON file and then search for attribute X, and like those kind of things where you don't really need to go to the nitty-gritty code. And maybe there are 50 different ways of coding that piece, but probably 40 of them work. Right? I think it's an accelerator, the same way as we kept on accelerating the languages as we moved along, right? Started with assembly, right? And then you have C, which is already an abstraction layer on top of that. Then you have Python, which is on top of C, but it's written completely different and gives you a bit more options. And then eventually you end up with JavaScript, and then you break the world. Those are completely, that's outside of the scope of this talk.
Now, I completely agree. And I think that's also where you see the limitations of this. Of course, now you have on the internet all these people saying, look, this website was entirely built by AI. Fine, great. Is it a great website? So whenever you have to build something a little bit more complex than your typical bubble sort algorithm, or maybe an API web server or something like that, then you need still humans in the loop that can figure out a way to build things efficiently and come up with an architecture, maintain it, right, review it. I think that level of complexity is still something that we should actually focus on. But at least we can save time for us just not having to remember how the hell did you, declare an array list in Java or or something like that.
Yeah, how to not get a null pointer exception. Right?
Yes.
Those kind of things. Yeah, I agree with you. When it comes to a bit more complex task, it can only be, for at least for now, an accelerator. And what we have seen so far is that we are kind of hitting the flat line of the amount of information that you can ingest into this model. So the quantity of information will not be the thing that is going to make an AGI just by feeding it into an LLM. To arrive to that, we need to go to something a bit different.
Yeah, and on this, I actually, again, shamelessly planting is something I heard, right? But again, on that podcast, one very interesting reflection that Grady does is, if you think about our intelligence, human intelligence, right? It's extremely embedded in our bodies, right? A lot of our intelligence comes from just the fact that we exist in body and not just in thought, right? So we have a sensor experience that actually helps us understanding reality and operating in it. And that is a lot of data. If you would imagine like the amount of sensors, quote unquote, that we have on our body, to do vision, to do tactile, to perceive temperature, sound, right? That's taste, smell, all these kind of things, like all this data that we receive on a continuous basis, and our brain is able to process and interpret and connect to memories and experiences. And out of that, you have a person, right? You have a general intelligence. And that's something that even a 1-year-old, as you very well know, already does very, very fast, right? Understanding touch, for example, or recognizing your parents. That's something that you can do, like image recognition, right? That's something you can do with a few, maybe weeks of life. So I think that in that sense, you have there's the difference. There's a big difference until you don't find a way to have these intelligences being in the real world, then it's going to be very hard for them to actually develop a general intelligence. They just have not enough bandwidth. And then we have to find very, very clever ways for them to actually get all this data, process it. It's not about how many GPUs you can throw at it, right? It's a very different problem. not necessarily a solved one. And I mean, the analogy, the brain equal neural network, breaks so many times, right? It's just like there's so many things that we don't understand. We barely understand the positional nature of brain areas. We don't even understand how brain waves are translate to impulses and everything. It's very far, I think, still. And I don't even know whether biomimicry, so reproducing artificial intelligence using the human brain as a template, is actually the only way. Maybe we will find another breakthrough in 2 years, or maybe in 20, or maybe in 50, who knows, right? But I definitely do not think that LLMs are the answer, right? There's so much more to be done before we actually boot up Skynet. I don't think we've found sort of the killer app for this technology yet. The best we've found so far is actually coding and help developers. I think that's the one that has the most industrial value so far. I think that is definitely sort of having an impact on the industry. But yeah, other than that, I don't know. It stands to be seen yet.
Yeah, and I think that's a great positive note for us to end.
Sure, absolutely.
I would like to thank Giuseppe for coming here and having this chat with me and being the first ever guest of this podcast. I would also like to thank you, the listener, for spending this time with us and hearing this chat. If you like it, share it with a friend. It will help the podcast. And if you know someone that has an interesting story that you want to share, reach out at contact@afks.xyz. Until next time, see you away from the keyboards.